Welcome back to the Linux for Beginners series. In our previous video, we learned how to install and manage software using package managers. But once software is installed, what happens when we actually run it? Every time we open an application or execute a command, Linux creates a process. In this video, we will learn what processes are, how to view them, monitor them, and safely stop them when needed. Whenever you start an application, whether it's a text editor, a browser, or a web server, Linux creates a running process. On the screen, you can see a program running a process and it passes to the Linux kernel. Linux kernel is responsible for managing all running processes. It decides when each process gets CPU time, memory, and other system resources. A program is simply a file stored on disk. It becomes a process only when it starts running. For example, the Nginx executable sitting on your disk is just a program. When someone starts Nginx, Linux creates a running process. As an analogy, think of a recipe book. The recipe printed on the paper is the program. When someone starts cooking using the recipe, that's a process. Processes don't stay in the same state forever. These are the states. The new state is when process has just been created. A running state, it's currently using the CPU. Sleeping state, it's waiting for something such as user input or data from the disk. Stopped state, the process has been paused. Terminated state, the process has finished or has been stopped. Every running process gets a unique process ID or PID. Think of the PID as the process's identity card. Linux uses it to identify and manage each process. No two running processes have the same PID at the same time. Now let's look at the commands we use to view running processes. PS shows the processes associated with the current terminal session. PS-EF shows a detailed list of all running processes on the system. PS-OX also shows all processes along with the additional information like CPU and memory usage. Both the PS-EF and PS-OX are commonly used. You will encounter both in documentation and in the workplace. Unlike PS, which gives us a snapshot, top updates continuously and shows what's happening in real time. You can see CPU usage, memory usage, and the processes consuming the most resources. If htop is installed, it provides a more interactive and colorful interface. Not every process behaves the same way. A foreground process occupies the terminal until it finishes. A background process continues running while you use the terminal for other tasks. For example, suppose you are compressing a very large folder. Instead of waiting for it to finish, you can run it in the background and continue working. Sometimes we need to stop a process. The kill command sends a request asking the process to terminate gracefully. The kill-9 forcefully terminates the process if it does not respond. Always try to normal kill command first. Use kill-9 only if process refuses to stop. Let's begin by looking at processes running in the terminal. We can use the ps command. It displays the process ID, the TTY, the time, and the command itself. To view all processes, we can use ps-ef command. It displays all the running processes on the system. The output shows the UID, the PID, the PPID, time, and the command itself. To monitor the system, we can use top command. Now we have a live view of the system. It displays the CPU usage, memory usage, running processes. We can type Q to exit. Now let's create a background process. For example, sleep 300 and ampersand. The sleep command simply waits. By adding an ampersand, we are asking Linux to run it in the background. On the display, you can see the PID or the process ID. Using ps command, we can also see that it's running with the process ID 5058. Now to find the process ID, we can also use ps-ef pgrep sleep. We can search for the background process also using pgrep command. Pgrep is a convenient way to find a process by its name. Now if we want to stop the process, we can use the kill command. Kill and the PID 5058. Let's view the process again. We can see that the sleep process has been terminated. We can also use ps-ef pgrep sleep. So now let's see how we can stop a process by using its name instead of the PID. So let's create a background process again. And verify. So we can see that the process ID of 5109 is created. So instead of using the process ID, we can use its name using the pkill command. Let's verify. The process ID 5109 has been terminated. Pkill lets us to stop processes by their name instead of typing individual PIDs. Let's look at some common mistakes. Mistake 1 is killing the wrong process. Mistake 2 is using kill-9 as the first option. Mistake 3 is assuming every process belongs to the current user. Here is a quick reference of the commands we learned today. We can use ps to view current terminal processes. ps-ef displays all processes running on the system. ps-aux lists all processes with resource usage, for example, CPU and memory. Top command can be used to view real-time monitoring. pgrep can be used to find the process by name. Can be used to stop a process using PID. pkill can be used to stop a process by its name. If you want to note these commands, please pause the video. Let's quick review. A process is a running program. Every process has a unique PID. PS displays processes. Top monitors them in real time. Kill and pkill stops processes safely. Now that we know how Linux runs programs, the next video or the next step is learning how Linux manages programs that should keep running automatically even after a reboot. In the next lesson, we will explore Linux services using systemctl command. Thank you for watching. If you found this lesson useful, please like the video and subscribe to follow the complete Linux for Beginners series, and I will see you in the next lesson.